Hello, welcome back. This is Calculus by Dr. Oz. Today we have three exercises in which we have parametric equations provided to us. So what we're going to do today is first having a calculator, having a graphing calculator ready with you. And we're going to graph each parametric equation together with the orientation on the curve. And at the end, we're going to eliminate the parameter so that we go back to the rectangular equation form, which is in fact the standard form that we're used to in calculus, y equals f of x type representation, or x equals g of y type representation. And let me just give you some heads up about what we are going to get at the end. So in the first case, we're going to have an ellipse with the orientation to be counterclockwise. In the second case, we have a hyperbola with its orientation as well. And the last case, we have another parabola coming with the orientation like this. In fact, this is a very specific one, but I don't want to give you a heads up right now. Please watch the video and then see what I'm going to say about this curve. All right, let's get started. All right, let's start with part A. We have x equals cosine theta and y equals 2 sine theta. And theta is a parameter, and these are all trig functions. And first thing to do in the list is to graph the curve. And please have your TA84 ready for that purpose. And you can pause the video at this moment and you can just graph it. And remember that you have to indicate the orientation of the curve. So parametric curves come with direction. Okay? So what I did here is, let me just show you what I did, and then please match this to what you are doing right now in your side. Okay, so I chose the interval for t values to be 0 and 2 pi because I know that cosine and sine are 2 pi periodic functions. So, and I gave the increments increment of like pi over 4 from one t value to another. Okay, so that I can use the known angles to get easy values to work with. You can have the unit circle if you want to from trig, and there's a formula card for that. And you can actually get those values without using your calculator. So when t equals 0, let's see where I start on the curve. So I got x to be 1, y equals 0. Here we go. I start right here, okay? I start somewhere on the x-axis, right, and see if I'm going to go up or down. Let's see. For pi over 4, it's x is plus 0.70 and y equals plus 1.41. So I'm still in the first quadrant. In fact, I end up being here. Okay, and you keep checking for t equals pi over 2. You got 0 and 2. Here we go. I can see where this is going. Okay, and I have to add the direction as well. Okay. But the question again here, is this turning like this or turning like this, turning like this? We don't know that. So to be able to see that, we have to keep adding more sample values here. Okay, so let's see. For t equals 3 pi over 4, x becomes negative and y is still positive. So it's like negative 0.70 and I'm talking about this part here. And y equals 1.41. So we're in the second quadrant and we got this point. So we're making a turn starting from the point 0 and 2. And then eventually when t hits pi, x is still negative, which is negative 1. And y is 0, so we hit x-axis. There we go. Okay. So now again, the question is like, how am I going to continue here? So is it going to go like this, or is this a parabola or an ellipse? So are the ends going to match or not? So again, to be able to see that, because this is not the full picture still, right? Because we don't know what's going to happen for the rest. So then keep adding sample points. 5 pi over 4, 3 pi over t, 3 pi over 2, 7 pi over 4, and 2 pi. And convince yourself that you get those points, and eventually at t equals 2 pi, you go back to where you start, and that's why you have a periodic curve here, because the parametrization is all about the cosine and sine, and these are 2 pi periodic functions. Okay, so this gives me like a good picture of ellipse. When you connect those dots by a continuous curve, which is blue. on the graph here. Okay, so what I want to do now is to get back to the rectangular equation form, and I'm going to use Pythagorean theorem. So here we go, Pythagorean. So x squared plus y squared equals cosine squared theta plus sine squared theta equals 1. This is the well-known identity, and I'm going to try to sort of make use of this identity to eliminate the parameter theta. Okay, so x equals cosine theta and y over 2 equals sine theta. Okay, sine squared plus cosine squared equals 1. So for that reason, x squared plus y over 2 squared equals 1. And this way I eliminate theta, and now I can write this in the standard form of the equation of an ellipse, right? So 1 squared plus y minus 0 squared over 2 squared equals 1. And this is an ellipse centered at the origin 0, 0, and A being at 2 and B being like 1. And this is a kind of ellipse whose major axis is vertical. And that's exactly matching with what we have found in the graph here. Okay? All right, so I think we got all done for part A, and please move on to my next video to see what I'm going to do for part B. Bye.